Hello, everyone. Welcome again to another exciting episode of Hazardous Area Safety. Today on the podcast, I've got Aaron Drew from Imperium Engineering. So, Aaron, I'd like to say thank you to begin with, and can you introduce yourself to the audience?
Yeah, look, Travis, thanks for the invite. It's a bit nervous here, but yeah. So I'm Aaron Drew. I'm the engineering manager for Imperium Engineering, which is an electrical instrumentation and control engineering construction business. Also happen to be the engineering manager for TotalEX, which is an online software platform for hazardous areas.
Okay. So the first question that we usually ask people to get the conversation flowing is about their career pathway. So let's go back to Aaron, end of high school, start of college, start of university. Did you ever was it a case that there were aspirations to go down this particular pathway? You fell into it, your friends were doing it. What's the story that got you to where you are today?
Yeah, my journey to EHA is convoluted. So when I left school, I did a pre-vocation course in refrigeration and electrical. I found that to be a little bit easy. Anyhow, I even though I did that was easy, I ended up joining the Navy when I think I was 17. Late 17, so in 1991, and I joined as an apprentice. So, the stream I chose as an apprentice was called an S-rate, a systems maintenance technician. Ended up doing a trade in electronic radio fitter mechanic. So, what I ended up looking after was missile and gunfire control systems. So, so the reason I say my progression to EHA is interesting. Certainly, even as an electrical engineer, when I was in the military, I was essentially blowing things up.
Yes.
And now my job is to try not to blow stuff up. So it's a bit a complete flip. So I was a tradesman in the military, and then I had a family and kids, and decided to make the transition to Civvy Street, which is currently where I'm sitting. And in that process, I needed to ensure I was employable, and so I started the process of further education, got an advanced diploma of electrical engineering, and converted that into advanced standing in an engineering degree. And I did an engineering degree by correspondence through University of Southern Queensland, which might take my hat off to anybody who does further studies like that, whatever it may be, as an adult when you're trying to maintain a household and look after your family. I can easily say that was the most difficult period of my life, was doing that degree whilst I was working, because at some point there I was on site doing 12-hour days and studying 4 hours a night, and that's not easy. And so anybody who's going through that journey, take my hat off.
Especially when you got kids as well. Another, I remember when I was doing my apprenticeship. So for the people, our audience who are listening or watching this, my background is I'm an electrician by trade, or I no longer have my license because it's a conflict of interest. I can't be doing the work and consulting in this space. But we had a few during my apprenticeship, and even when I was a young tradesman, there were team members who had come from military, whether from Navy or Air Force or Army, that were doing they basically had to do their apprenticeship again because there was no alignment to qualification. So because the stream towards your qualification wasn't recognised within the Australian RTO framework, it was either, okay, you're back at first year apprentice, even though you have this vast experience. Is that what you came
Absolutely.
against when you were thinking about that transition?
Yeah. So look, the Navy, or the Navy military, whichever one service you're in, they don't train you for you to step out of the military and take up a role in civvy seat straight away.
Yeah.
They train you for the job that you're going to do. And strangely, when I did my apprenticeship, I was the second last intake of apprentices because they made the decision even back then that was a pathway. You're sure they'd provide all this excellent training and then people would just walk out and get a job in civvy street. It was too easy. That's not to say that they don't have further education pathways within the military. They do. They have excellent ones where if you're self-motivated, you can get subsidised for that training. But you're absolutely right. The trade that I got, I could get a Class B license, I think, relatively easily. But even with the engineering degree that I did, electrical engineering, in order for me to get an A grade license, I would have to essentially start from scratch.
Yeah.
And as a chartered professional engineer, there's absolutely no incentive for me to do that.
You don't want to crawl up in a roof space clipping cables.
Well, look, and this is one of the things I'll talk about a little bit later in the software that we've developed. I've got a lot of the competencies in hazardous areas, which include the construction and the inspection competencies. But I don't allow myself to do that. I got those so I can understand, what the requirements are for that type of work. Not so that I could do it myself. And I don't have enough familiarity with inspections and with installation activities in order to be able to do that. So I just wouldn't do it. I understand the concepts. I just personally don't do it.
So, if that is the case, how did you go from military to studying, completing your degree, like going through, and you've kind of gone about it the hard way. You've gone apprenticeship in the military, then you've come out and done a degree and then a diploma, then an advanced diploma, then a degree. That's a big transition. So, and then you've gone, okay, let's now focus in on hazardous area. What made that transition, or were there factors that made that choice? Were you like, well, I've been military, I like explosives. Talk us through that.
I don't know whether I like explosives. I get nervous around them. So look, I don't think it was I don't think there was no goal for me to head into that explosive hazardous area space. I consider it a string to my bow as an engineer. I have a couple of other specialities that is earthing and power system protection and arc flash and so on. So it's a couple of things which I do. But the way I fell into it was so I was actually quite lucky in when I did my advanced diploma. I'm not going to say I'm a brainiac, but I'm not stupid. I was able to do a lot of those units very quickly. On the back end of that year, I got some work experience with Worley Parsons. But this is before they rebranded as Worley. And in that time, I did a power system protection study for the Rock Oil project, and the engineering manager at the time, Tony Gleason, who I'm still in contact with, he extended an invitation to me when I was ready to get out of the military. He'd have a job for me. So that little bit of work experience and industry exposure made it, I wouldn't say easy, but it certainly gave me a path to getting out of the military and being assured that I had a job when I got out. And all I needed to do at that point was continue my studies down the path of engineering, which is what I did. And because of the processes I followed within the military, I had that engineering degree subsidised 100% by 100% whilst I was in by the military, and then obviously when I got out, I clearly needed to pay my own way in that regard. But so then when I got out of the Navy, I took up a job with Worley Parsons, And the project I got on was the Dampier Bunbury Stage 5A2 project, which then it sort of morphed into 5B. And I wasn't even in hazardous areas then on that project. I was looking after power generation, the generator package, synchronization controls, and so on. I did touch on the hazardous areas, but it wasn't a full blown part of my job on that job. But then obviously with Worley being in the hydrocarbons space, I got training in hazardous areas. What was the fella's name? I can't remember his name. Inlec. His name escapes me. But he was, did all the classification competencies and so on. And then I was playing around with the Neerabup gas pipeline and compressor station, and that's really when my hazardous area journey sort of started.
So coming back to that's a pretty broad spectrum. And how long was that period of time? Are we talking 5-year period between going away?
Well, from when I got out of the military, now the 5B project I think it might have been maybe 2 years, because I went to site as well, and that's where I was studying my engineering degree whilst I was on site. And then I think the pipeline project after that, the Neerabup project, I think that might have been another year, and then I made an interesting sort of segue. I stepped sideways from oil and gas into mining. So it was about a three-year period where I was in the oil and gas industry, and then I jumped ship into the mining industry, and I actually started as a lead engineer for the Cam 2 copper mine project in the Adelaide Hills, which and that's actually where I got my first real exposure to EEHA in the mining environment. And turning the clock back, I think in 2015 I did my first presentation at the EEHA conference, and that was actually my topic. Was EEHA in the mining environment. And it was, a lot of people will understand this. 98% of the audience had absolutely zero interest in my discussion. Them all being oil and gas people, they're like, why is this even here? And certainly there was a few eye rolls. The regulators were quite interested though. They, I think, made up the 2%.
Well, it's funny you should say that about the regulators to begin with, because the reason typically, we're talking about Australia here, typically mining regulation sits outside purview of technical regulatory officers. There's a different regulatory office, there's a different framework of how they dictate, because everything more performance based, and it's a lot more risk assessment. There's more risk assessments done within the mining sector to be able to develop tolerance for that risk in first principles. And for example, if you're outside the mining sector, everything else, if you're not an entity, if you're not an electrical entity, AS3000 solution will work. That's your legislative pathway. So there'll be an act, there'll be regulation that will call up your mandatory standard being AS3000, then your hazardous area portion falls under it. That's it in a nutshell. There's different trigger events and different reporting functions and all that kind of stuff. But when typically in the mining sector, this is why it doesn't get the spotlight on it like it should. Everything's risk. There's a risk assessment done, and it's risk-based approach, and then it's up to the PIC person in charge of that site to determine, and also the chief engineer to determine if they're going to accept that approach or not. So how did you find that? Because that's how it's been for a long time.
But at the end of the day, you bring up AS3000. I think it's clause 7.71 or something like that. at the end of the day, the operator of the facility has got a responsibility to maintain a certified plant where they've identified that they've got explosive hazardous areas. So it's more about. I found that journey in the mining space was more about education and educating people. It's certainly in 2015. I wouldn't say there was resistance to it. I would just say there was a lack of knowledge.
There is a lack of knowledge,
and that's why. And I actually think that's where my passion for education of hazardous area exposure to certainly in the mining environment happened. I think in the oil and gas industry, because in mining it's not their core business. In the oil and gas industry, it is their core business.
Yeah.
So clearly, there's a greater understanding, although sometimes not as much as you'd hope, depending on which company you're dealing with. Certainly, in the oil and gas industry, there's a greater understanding. In the mining industry, they at the time in 2015, they didn't know what they didn't know, and more importantly, I think they were. And I'm going to speak very generally here. I wouldn't say there was a willful disregard for it, but there was an attitude which was, well, this is just going to be an embuggerance and it's onerous. So there was some avoidance happening.
The challenge is now the mining sector that we've worked in is typically on the eastern seaboard, so it might change from state to state. It might be different in WA. I don't know, but I know that within the eastern seaboard, you've got very much, particularly within the mining sector, because they're utilising fire damp, they're very prescriptive.
Yeah.
You'll determine, and this is why it doesn't get the spotlight that it should. You determine your mine depending on function first, whether it's open cut or quarry, underground, and then depending on that particular arrangement, you will then define your hazardous risk zones that are not correlated to what we would commonly refer to as a hazardous area. And they've got zone 0, zone 1, zone 2, but under that regulation, they're not correlated directly to zone ours, like zone 0, 1, 2. Yeah, so it's different magnitude, and then
that's coal mining you're making reference to.
Yeah, coal mining is making reference to it, and they're also quite prescriptive. They're quite prescriptive about. They're quite prescriptive on the portion about explosion protection techniques. So the EPL requirements they haven't really worked that out within their mining regulation. They haven't gone, well, if you have this, then the EPL for that particular device should be this. It's just EXD for EXD, EXIA for this zone, EXIB for that zone, and this is what you can use in these particular environments. So the knowledge of how to get a particular device and how to understand its marking, that knowledge hasn't kind of transitioned into that field from my experience within coal mines.
Yeah, look, I can't speak with any expertise in the coal mining environment as I've not been exposed to it. I've done oil and gas and reagents facilities on surface mines. Yeah, I've done underground magazines and those types of things, but I just haven't been exposed to coal mining, so I can't talk with any knowledge of it.
So where did the passion come from?
So the passion for HA for me is it's not really easy to explain. I'm one of the things I pride myself on with the business that we run is, we operate open and honest and what we believe to be a fair business. So we do, we've got pretty low rates. But we do a good job with the people that we've got, and most of our clients and customers are repeat business. It's about getting that first look at a client. So in doing that, I find the EHA space, there was a lack of knowledge and a lack of understanding, and I felt like I could fill that void. And I can speak with, at the time I was obviously still learning and feeling my way, but over time you get good at things. Again, I don't think I'm the best EHA engineer on the planet, but I'm certainly not the worst. But I found that I enjoy teaching. Like as a tradesman in the military, and it blew me away when I got out of the Navy. It absolutely floored me. Every single tradesman that came to me, or junior that came to me, they could either read schematic diagrams or they couldn't. By the time they left me, by the time they left my department, they could. Because I spent the time and I was interested in growing them as a person, so that when they left, they were a better tradesman. And when I got out of the military on that job that I was talking about for the Damper Murray pipeline, there was, 25 Sparkies, only 3 of them could read schematics.
Yep.
And that floored me. Like I didn't understand how that was a thing. Obviously, a few years later in the industry, I understood that most Sparkies actually don't get that. That exposure. Not that they can't do it. It's just that they don't get the exposure. And when they do get the exposure, I don't know what the percentage would be, but only some of them are capable.
It's not so much. I don't think it's a case of capability. I think it's a case because we have generalized stream for training.
Yeah.
For say certificate 3 in electrotechnology to be an electrical technician, electrical practitioner, electrical mechanic, whatever. Each individual state. We're just talking about an electrician. If you get into the funny thing is, if you were to do your instrumentation, obviously, then you'll understand how to understand schematics, because instrumentation is part of that. And funnily enough, if you do work or do an apprenticeship within refrigeration mechanic, to be a refrigeration mechanic, there's a lot of schematic interpretation within that, because you have to understand, obviously, P&IDs and stuff like that as well.
That's what I was getting to. Like, it's a lot of it's to do with exposure and what the job is, what the job role that they're doing day in, day out. And so not everybody gets that exposure. But when I was in the military, we were looking at schematic diagrams. Maybe daily is probably an over exaggeration, but certainly when you've got a fault that you've got to fix, you're ripping into volumes and volumes of schematic diagrams, because we fault found down a component level.
Yeah.
So we weren't just replacing circuit cards. We would replace items on the circuit card.
Yeah, that just doesn't happen because of time.
And it's not like that now. Like, I think I'm pretty confident that the way they've gone with it is, black box sort of level fault finding. You don't go inside the box. You just go through a flow sheet, and all of a sudden you know where the fault is, and you just replace that box.
That's a really interesting topic that you've raised, because you're not the first person who's left the military to say that. And I think it's a case that with military training, because it is such, it goes down a specialized stream, not a general stream. And if there's also a requirement, and correct me if I'm wrong, that when you're on barracks or on if you're deployed or anything like that, on your downtime, you're always sharpening your tools, so to speak. You're always learning. There's always better ways to do things, and because of that specialization, that focus, there's I wouldn't say better, but there's just a different approach to training. Yeah, it's more regimented and strict within military.
Necessarily it is. The training you go through is pretty high level.
Yes.
And I don't mean high level as in not specific. I mean, it's pretty concentrated in certainly on a warship, you're immersed in it. It's not.
Yes.
It's not like you can go down the street or go play a game of cricket or tennis or whatever.
There's drills as well.
We did. Yeah. So when you do you get a ship ready to go to war, we used to call it workups. Presumably it's got the same name now. Then you'd have the green slime come on, and we call them that because they the guys in the green overalls and C training group, and these guys were in that position because they were recognised experts in their field, and so they would come up with scenarios whereby the ship would essentially fight a war and fight damage and floods and fires and explosions and so on and so forth. But they'd also go down to the technical level where they would know, there'd be a technical expert on your system that would come in, and during the scenario, they would be putting faults on your system. So you're in the middle of, fighting, to keep your ship alive, power outages and all sorts of things. And in that same time, understand there's a reason you have a warship. You have a warship so you can put the fire control system in a particular place in space and time so that you can shoot missiles and guns, right? So, and I'm not saying that other areas of the ship aren't important too, because if you're sinking, it doesn't matter about your fire control system. But certainly there was always a very big focus on making sure the fire control system was functional. So we always had that. I had the people putting faults on and all that, and that's just a regular part of business. But then there's the general maintenance routines and so on. So, and you get pretty good at that. To this day, I can still tell you which potentiometer or what circuit card to do what setup. That's how many times I did it. It's not because I'm overly bright. It's just because of repetition. And I think in the new systems like the air warfare destroyers, and I was on the Anzac class for one deployment to Iraq. Certainly, you didn't have to go to that level of set to work on your fire control system. It was a lot more computerized and, to be perfectly honest, easy. It was. I wouldn't say it was a holiday, but it was easy.
Well, it seems as though that experience that you received in the military and the exposure that you received has helped, not obviously your transition, but helped you to be able to find areas of improvement within the work environments and the companies that you've worked with at the moment. And that's led you to HA. So what made the decision to leave a company and create your own business, and also go one step further and start software, start a SaaS company in hazardous areas?
Yeah. So that's a really good question, and not an easy answer.
We got time.
Yeah.
We got time.
So I spent 16 years in the military, and from a technical perspective, loved the work that I did. Show me a guy who doesn't want to shoot a missile, blow something up, and watch it explode. That's a rush. And it is a rush. Like, you press the button, and you momentarily lose the target. It's like, hang on a minute, and you go into panic stations to try and reacquire it, so you don't waste the shot. That's $2 million flying off the end of the rail. And then in other instances, when you're shooting the main gun, you're putting up a wall of lead in the air, and you watch a lot of fun, right? So so technically and from an operational perspective, I really, really enjoyed the job. Me personally, I wouldn't say I have a problem with authority, but I always find that I gravitate to senior positions and leadership and management type roles. I think I don't know too many military people who don't actually have that in them. I think that, sure, there's some that are just happy to just. I can think of one I had a beer with on the weekend. Instantly, he no drive,
no ambition.
No, he's not interested. He's happy to just go with the flow. But a lot of us are the flip side of that, and we always, whether we do it naturally or we gravitate to it, it just happens. So I found myself in a position where I took that role at that company for the Camman 2 copper mine. So in the engineering industry, people take up contractor roles. Yeah. So I started myself as a PTY LTD, and it just grew from there. And I was actually headhunted after my performance on that project to become a part of another company, which one of those guys is now my business partner with Imperium Engineering. So it sort of just naturally progressed that always seemed to get into, leadership positions, senior positions. And one of the things you mentioned earlier about there are traits that military service provides. And I actually had a mate's 50th that I joined the Navy with on Saturday night. And it's funny, there was a bunch of us that all joined the military together. We went to our apprenticeship training together. And we have the same story, arguably, where we just find ourselves gravitating to positions of leadership because I'm just fundamentally unable to sit back and watch something fail. I don't have it in me. I can't do it. Regardless if there's somebody in a position, I'll first try to help them to get us going in the right direction. Should that fail, then I'll just step in and do it, whether I've got the role or not. Maybe that's a personality failing of mine. I don't know, but I just can't watch things fail. Now, so there's an interesting progression here as to why we developed TotalEX as a software package. And you'll know this from experience, and I'll be extremely surprised if your audience doesn't resonate with what I'm about to say. And I say this at HA conferences all the time. I said, if you're not managing your HAVD in a spreadsheet, sure, there's systems out there where you don't now, but I'll call you a liar. And the problem with spreadsheets, because of the massive volumes of data, depending on how big your site is, you miss things, and it's easy to miss. Like we've developed a software package where we can check the compliance of a tag in 50,000 tags, for example. Like, give me 5 seconds or 10 seconds, and I'll run your data through my software, and I'll tell you exactly where your failures are. We did this for Baker Hughes on one of their jobs, which they were still in the process of doing. So they loved it. The guy, I think he's Matthew Thompson. He said, I just saved him 2 weeks worth of work, and it took me less than a second. So the passion for me was, there's got to be a better way to do this. Again, I can't sit back and watch something fail. I just don't have it in me. So I thought about it, and I approached my business partner, Greg Rossiter, and I said, well, look, we can do something here. We can make it, I think, a meaningful change in the industry in terms of make a better system for people to manage their engineering, their construction, and their inspection, and hand over something to a client. Because this is where it really gets difficult, is that process of handover. Say you've got a large project, call it 20,000 tags, for example, and you've got to hand over HAVD. Then the receiving end, they need to review that information, right? And they need to go through. Hopefully, they've been part of that process during the project, depending on the contract strategy. There may or may not have been. But when that HAVD handover comes across, then somebody's got to do their due diligence on it, because the operator then becomes the responsible party. And if they've accepted something which is not right, then they own it now. So they're now doing it. So we thought there's got to be a better way to do it. And so and sorry about the plug here, but this is one of the reasons why we developed it, is and extends to vendor packages for a project as it's being constructed. That handover process, if you hand it over in a software platform where it checks the certification and compliance of your tag, then arguably all you got to do is scan it, and you can even just look at the dashboard. How many tags have I got? 21,350. How many of those tags are certified true and correct? 21,350. What's more to look at? Then you can go through and you can have a look at all of it as you please, but the system won't actually let you fail. So I don't take responsibility for the veracity of the documentation that's in there. I'm not owning the IS calculations. I'm not owning the classification. These are all loaded into the software, and I require a person who is competent in that specific thing to sign it off and accept it. And then once that's done, obviously you get an inspection done, then a tag becomes certified. So in this way, there's no gaps in terms of the areas classified 2B, T3. the equipment's suitable for 2B T2. Well, it doesn't work for a 2.3, does it? T3, right? So the system will pick that up and say, well, that's not good enough. Whereas if you've got a 21,350 tag list in a spreadsheet or multiple spreadsheets by area or whatever, there is the possibility somebody's going to miss that. So when we got the system up and running, and again, but I don't pretend to be, the best engineer in the world, but well, I like to think I'm pretty good at it, EHA. On a couple of our clients' jobs, we ran our spreadsheet through our software, and we found a couple of errors that we know. And again, I'd like to think we're pretty good at it. And then we went back to those clients and offered to fix that for free. And so that improved our system, and obviously the client's process as well.
The challenge that a lot of clients find, and this is from my perspective and my experience within Zero Industries, not as assisting clients, we find that because we often find that vendors lead clients down the garden path. I'm not saying they're intentionally unaligned. I'm not saying that they're bad actors.
Yeah.
I'm just saying that they've been fed information from someone, whether it's from someone within the company, from marketplace, whatever it is. Yeah. And they're trying to get a run on the board. They're trying to close the deal. They're trying to do a sale. Kudos. They're trying to do the hustle. But and we typically work with, the majority of our clients are all legacy sites. We deal with legacy sites. We don't deal with greenfield or brownfield sites, or very rarely. So we come in after the plant's been operational for 5, 10, 80 years, whatever it is, and problems are coming up. And it's a case that the first thing that we ask their clients is, okay, do you have just a hazardous area standard? Now, we're not talking about this
like a
60,000. Yeah, we're not talking about the 60,079 series. We're just saying, how are you handling hazardous areas? Do you have a document that can point us to, oh no, we don't have that.
Yeah, and that majority of the time they don't, right?
Yeah.
Because again, it gets back to they don't know what they don't know.
And they're getting vendors to be able to...
Yeah. And the vendors take advantage of that lack of knowledge. I'm not saying they do it all the time intentionally.
It's not intentional. I don't think it's intentional. I think it's a case that the vendors are just trying to do the right. They're trying to do the right thing and provide the service.
They're trying to sell their product with against the specifications which they normally produce them, with the lack of understanding in some instances that the standards in Australia are required to be done a particular way, which is not what they would normally produce.
Oh no, I think it's even more nuanced than that. To be fair, I think it's a case that with vendor packages, I think that they're trying to utilize general learnings and general observations, and they're trying to fit a round peg into a square hole.
Yeah,
because they'll be perfect example. Perfect example, dust collectors, and probably half the DCU manufacturers are going to hang me out to dry here, so sorry, boys. But they'll provide a classification. They'll sell the piece of kit with the classification associated with it. Fine. But that hasn't taken... But when you talk to them about it, you go, guys, did you get this dust tested? Is there any lab results for it to make sure... What's a particle size that it's done? What's this? Oh no, we weren't provided with that. We're just going off general information. All right, what about the transfer rates? What about the flow rates? What about X, Y, Z? Oh no, we haven't really considered that because that's outside scope. And it's a case that happens more times than it doesn't. And what we recommend is, if you get your management document, if you get your company standard about how you're going to scope a project, within that technical scope, there's going to be training requirements, there's going to be handover requirements, there's going to be milestones within the project, there's going to be vetting of contractors, there's going to be there's going to be
There should
platform.
be.
Yeah, there's going to be a platform in which this is how we expect you to behave while you're. This is what we expect you to address during detailed design. This is what we expect you to address with the construction phase.
Again, it comes back to the client and lack of knowledge, right? So getting back to your original point about why did I get so passionate? Why did I develop this software package? So that end user experience, I think, is a primary reason.
Yes.
But vendor packages, right? So there's got to be a better way to do it, right? So the traditional engineering, they'll submit their documents and the engineer will review it and approve it and yada yada yada. And the inspections happen, and so on. And then you find on the inspections that there's an ATEX certified plan, or there's some associated equipment which isn't right, or the primary equipment was listed as being IAC certified, but it's not. It's CSA or FM Global, whatever. That whole process is just, and then you only find this information out when it lands in Australia, right? And you do your little review on it if you didn't do a QA review overseas. So part of the software drive for developing the software was to actually make and this is why Baker Hughes like it, right?
Yes.
Is because they're a vendor, right?
Yeah.
And and they've got to comply with the Australian requirements when they sell product into Australia. So, if you develop the vendor package as a project within the project, you can see it's certified before you accept it, and the whether it's the EPCM or the client engineer gets to operate within the workspace of TotalEX, gets all of the information, and it's legit all there. And so before that device, that package, or whatever it is, gets released to be sent to Australia, you know everything there is to know about it from an EHA perspective, because some of the projects I've been on, and they'll remain nameless, but the amount
we'll get cancelled, Aaron, quick.
The amount of vendor packages which literally got stripped back to the pipe and the supporting structural pieces, you couldn't count them. And so the issue that I really have is with that is, not fabricating some of these things in Australia, because it's slightly cheaper to fabricate them overseas and get them sent over to Australia. The bean counters, and I use that generic term that we all know and love, that they never account for the total cost of getting one of these packages approved on and operational on site. So when you're stripping something back completely and you're throwing all the instruments in the bin, because they're all ATEX certified and there's no suitable replacement, yada yada yada, whatever. They don't take into consideration that total cost of getting a piece of equipment operational on site. Sure, old mate's procurement bucket's great because it's 10% under budget, yada yada yada. But I always go back to the $1, $10, $100, $1,000. $1 spent up front, smart in feed is worth $10 in detailed engineering. Is worth $100 in construction, is worth $1,000 in commissioning. Yeah. So if you make some smart decisions at the start of a project, you're going to save yourself oodles of money at the back end. Yes. And if they actually added up the total cost of execution of these packages that get made overseas, come into Australia that are in EHA areas, and the amount of rework that needs to get done in order to get them turned on, maybe it'd actually be better to get them made here, or employ a software package like mine, sorry, shameless plug, and make sure it's certified before it comes into Australia.
There's point number one, there are specialist manufacturers of equipment that we don't have an industry for to be able to have scale in Australia. There, and that's typically around milling, processing, at large scale, say pack
Yeah.
lines, pack
Yeah.
pharmaceuticals, that kind of stuff. We don't have that. Majority of that stuff comes out of Canada. There's a fair amount. Then you've got motor winders and stuff come out of Finland. What we're seeing with the trend that we're seeing lately is, particularly in dust, whether it's whatever kind of dust it is, we're seeing prevalence of EXH, or we're seeing vendors who say that their device is certified. It's technically it is, but it's not. So how would, and I'll give a real life scenario, and I'd like to see how your thoughts on it, and also see how your software would handle the complexity of it. So, get back to dust collectors. I might be harping on about it, but it's just an easy scenario. They're saying that their device is IEC certified to EXH. Do you know what EXH? You know what EXH is?
Yeah.
EXH.
I know that's not in my software.
Yeah, so EXH is an 80,079 requirement. It provides a certificate of conformity, and it's for non-electrical equipment. So they say their their dust collector unit is certified to EXH.
Yeah, mechanical equipment is essentially what you're saying.
Yeah, but how's a dust extractor unit going to work if it's EXH? As soon as you plug it in, it's an electrical piece of equipment. What it is, the technicality of it, there's two portions to it. So it's saying that the internal confines of the collector unit is certified to EXH, so it's not going to create a spark that has a temperature rating, but it doesn't capture anything on the outside of it. Then in the certificate of conformity, you'll see that there's applications for it. So when the package arrives, it's seen from a standard perspective as it's just on the tip of my tongue and I can't think of it. It's seen not as a standard apparatus, but it's seen as an assembly.
Mm.
So therefore, what the vendor goes and sells their wares to a client. The client goes, "Oh, great, we've got a device that's compliant to IECEX," because that's what they've been told. Technically, it is, but when you start unpacking it, it's not, because you have to see it as an assembly. Therefore, it's a case that you need all the other associated certificates of conformity. 9 times out of 10, because these companies are manufactured in Europe, they come with European motors. European motors won't work in Australia. Therefore, they can't deviate from the equipment schedule list on the certificate of conformity. You're not given a design of how the system will work. So you receive a technical document. You receive the IEC certificate of conformity for the dust collector. Then you receive IEC certificates for the other things, but you haven't got a design to understand the complexity of how it all operates together.
Mm-hmm.
So that's what we're seeing happen from vendors in the dust space, in the food processing space, in pack farms, in pack nutrition, that kind of stuff. How would your system be able to handle that complexity?
I think so. So I'll speak to that with an example of my own. For example, you go to a large electrically driven compressor,
yes.
And you've got call it a 2 megawatt motor, for example. That 2 megawatt motor will have, say 32 child tags associated with it.
Yes.
Vibration sensors, temperature sensors, all that type of stuff. So the way we built the software is you have that parent-child relationship in there. So I would suggest that that EXH certificate would be against the parent tag, and then there would be all the child tags underneath it, which would then themselves need to be certified. And so the parent equipment wouldn't be in our system wouldn't be considered certified without all the child tags having themselves being certified. So you'd need to if they were electrical, or instruments or a motor, for example, then they would themselves need to comply with the relevant standards and inspection requirements and engineering and so on. So if the overarching, we literally just did this. I am very confident. I actually got an email about 20 minutes ago that the guys actually doing the inspection reviewing process right now after we uploaded all the set up their project and for this vendor package piece of equipment. Where we had that exact scenario. So the overall device came with ATEX certification. However, all of the elements within it were all IEC certified, with the exception, I think, of an RTD, which we needed to do some trickery with. So we put all that together, and all of a sudden, on the component level, it's certified to IEC EX, and so that's passing through the system now. And so I would say the same thing with that dust extraction unit. Yes, the vendor is saying it's EXH, and that covers the entire thing, but
covers the internal.
It's internal. From the way they sell it, it covers the entire thing. But I found that the people selling this equipment, don't have as detailed an understanding of the device themselves. So the salesperson says it's IEC EX certified,
which technically it is. Like there's no. It's not. A lawyer would have to argue whether it's misleading and false advertisement. It's not. It has an IEC EX certificate. Expectation versus reality. That's a different.
And that's where. And so this is where I find the vendor acceptance side of our software is it put all that to bed. If you had that put in the system before it was shipped, they would have to put all the tags in all the electrical instruments and motors and junction boxes and so on. They put them in the system because they're all a part of that one device, and you very quickly determine that it's not going to pass an acceptance criteria.
And that's from an equipment level, but you're still requiring some individual to validate the design as well as a separate task. Is that correct?
Yes. Yeah. So we look at the
yours
EHA
is equipment centric. Yours is
EHA compliance only, right?
Yep.
So we, if it has a SIL rating or safety integrated functions and all this type of stuff associated with it, we're not looking at that. I mean, we may extend our software into that realm. Should one of our clients be interested in going down that path and having the whole gamut in one place. But for the moment, we're doing EHA compliance equipment certification. That's it. We've toyed with the idea of doing a more broader software package, like a parent package for this one, where this would be one license within a suite. But we're just going to concentrate on this one for now because
it'd be too difficult. It'd be far too difficult.
And there are packages out there which do that equipment class libraries and all this sort of thing. The EHA, and it gets back to that passion question that you raised earlier. Do I have a passion for structural, mechanical, pipe, civil engineering? Absolutely not. I just no, not interested. Electrical instrumentation and control, sure. That's where we play, and that's what I like doing. And I think EHA is a specialisation within those fields, and it's something we seem to be pretty good at. And our software, as you just pointed out, then it's not dealing with the functionality of a piece of equipment. It's dealing with the equipment.
It's purely Part 17, realistically, purely
right.
Part 17. So you're dealing with it's equipment centric. It's equipment centered.
Yep.
It's ensuring that the equipment's captured. It's scheduled in to preventative maintenance. The
That's
people
right.
that are conducting the inspections are competent.
Yes.
They're carrying out their mandatory requirements.
That's correct.
And it's flagging any change of management or
Yes. So
necessary change.
that's right. So one of the things that we're able to develop over time in the software is recommended maintenance regimes. You know how there's the continuous supervision model, and obviously, in an attempt to save money, people go down that path. But in my opinion, the only way you can really do a continuous supervision model properly is if you actually understand your plant. Do you understand the failure modes of your equipment within your plant? Do you understand it to the system level? Do you understand it to the area? Because for a big facility where you've got multiple areas and it's spread over quite a large geographical space, some might be close to the ocean, some inland. You might find that in an area that you have different types of equipment, different manufacturers supplying equipment, pressure transmitters and temperature transmitters. You might find over a period of time that when you're doing inspections on these devices, they're failing in a common way.
Yes.
So it's not common to a manufacturer and it's not common to an equipment type, but they're all failing in a similar failure mode. And we've actually built that into our software about how you fail. What sort of failure is it? And there's a failure mode tree and so on. So over time, you get this understanding of how your plant is failing, how your equipment inspections are going and so on. And then, we haven't done it quite yet, but we're very close to doing it, is doing this recommended inspection regime where we can say, okay, you put in your criteria of, zone 0, 100% inspection, obviously. Zone 1, we want to do these types of inspections in these areas, and so on, zone 2. And then the system, after a period of time of your inspections, will actually begin to understand that, this particular area here, not such a good idea to do continuous supervision in that area. Or if you do, you need to do, monthly visual inspections or whatever that case may be, so that you can be on top of, failure modes of equipment because you've got a known process of failure and a known vector for that happening. So that's where we're going with it. And so got some other interesting things that we're going to do as well.
So if that's the case, where can people find you?
So we've got a website, TotalEX, so total-ex or hyphen, I think it is, .com.au. Alternatively, I'd really like people to search the live HAVD. That should pop up first in your Google search, and the more times people type that in and click on the website, that'd be great. So that's where we're at. You'll find the website actually tells you a little bit about the software. But one of the things we've got on there is we've got a data set example. So one of the things that we've done with our software, because we check the compliance of a tag, we've actually provided a spreadsheet online, and here you go. Oh, this guy's talking about spreadsheets. He says he doesn't use them. Well, I know that people do use them. So I can do a compliance check on your data. So all you need to do is you need to download that spreadsheet. Either you can give us your data or you can do it yourself. You can put your data into our format and then send us an email, and we can have a conversation about running that through our compliance filter. So the compliance filter is separate to, well, I wouldn't say it's separate, but when we put a company's data set through the compliance filter, and I literally just did this for a mate at Chevron, didn't take his data into the system, did it just through the compliance check, and only took a really small sample of it because I didn't want to give too many things away. We can run it through our system to do a compliance check, and whether it's 100 tags or 20,000, I don't care. It just might take an extra second or two. I can tell you exactly what's wrong with tags. So we did this for Baker Hughes about 18 months ago. 595 tags. It took 0.3 of a second. and understand they were still going through the engineering phase, so this isn't what they handed over. I identified 146 non-compliant tags, with all of them with multiple areas of failure. But it identifies exactly where it's failed. So now you've got a to-do list. Now you know exactly what's wrong with your data set, and now you know what you've got to do to fix it. And, his words, not mine, that would have taken him 2 weeks to find all that if he found it all, right? So our data spits out fails with a red, and in brackets it'll tell you how many failures there are against that particular tag. So that's the website, totalex.com.au. That spreadsheet's freely available on there. And if people want us to have a look at their data, then sure, we can do it. It's one of our selling points is, I forget exactly what the numbers are, but I think up to 1,000 tags we charge $500, and might be 5,000 tags, 1,000 or something along those lines. Either way, we've got a tag-based structure of doing those compliance reviews, and it takes it. The reason it costs is because how much time and money we've actually spent developing the software, right? It doesn't take us a lot to do the check, but it's a check which will tell you exactly what you need to do in order to make your facility compliant.
Fantastic. Well, I'll if you can send me those show notes or send me the email addresses and stuff, I'll put them in the show notes below. So, well, we've just clocked over the hour. So thank you very much, Andrew, for jumping on the call today and going over your history and also sharing with the developments around TotalEX software system and your experience. So thank you very much.
No worries, Travis. Look, I really do appreciate the opportunity to come on and have a bit of a chat. I know we've met a few times at hazardous area conferences, and we always have a good conversation. So I'm glad I was able to come on and talk a little bit about me, because I'm my favourite topic.
Oh, come on. It's getting almost Christmas time.
So, really do appreciate it. Thank you.
No worries. All right. Thanks, Aaron, and I'll talk to you guys later. Bye.
See ya.